So first of all, thanks everybody who came to my talk. I always appreciate you guys have choices, and it's nice that you want to come and hear what I have to say. As mentioned, so I'm Joe, CTO, co-founder at Librato, and I'm really thrilled to be here at SREcon for the second one. When the first one popped up, I think it was literally the day of it, I saw the internet article, and I was like, oh, that's such an awesome idea for a conference. And a big reason I'm interested in that is, so I'm at Librato, SREs, and people who may not have that title but perform those kind of roles are really near and dear to our hearts, because we build and provide, for the last 4 years now and counting, I guess, what we feel is a pretty decent, awesome, world-class real-time telemetry system. So if you need to chart things, if you need to see when things move, and you don't have your own stuff in-house, we're the kind of people you talk to. But today, I'm here to talk about both kind of the history and evolution of our feature flagging infrastructure, and from when we started with a really small amount of traffic as we scaled through several orders of magnitude, and moved from being able to just kind of feature flag in our front-end application to our whole data hot pipeline. And then a particular story about Collin, who's one of my colleagues, and how he leveraged it to rip out and replace a pretty core piece of our infrastructure without any downtime or noticing from our customers. Before I get going really quickly, I want to give a quick shout out to Dave Josephson, who is a much longer time affiliation with USENIX than I do. I think he has a column in Login magazine too. But he and I are partners in crime on this talk. And so in addition to being much better than I am at having luxurious hair and wearing scarves and playing music if you note the guitar, a lesser-known fact about Dave is he's also the metrics monitoring world's equivalent of Banksy. So here's one of his pieces of work, and then as a old-school NES fan, this is another one that I'm pretty fond of. So just assume that anything like particularly witty or insightful today is probably Dave's work, and anything that maybe falls flat or is a little dry is probably mine. Okay, so feature flagging. If you think about, and I give a decent number of talks, and a lot of times I always say, okay, continuous delivery, because a lot of what we're doing is building a product that helps with continuous delivery. And I always, I think of it, fundamentally as these 5 pillars, right? So we need to be able to, when we merge code into master or trunk, we need to know that it passes all the functional tests. We need to be able to do automated deploys. There can't be any kind of humans in the loop on those. Today what we're going to be talking about, feature flagging is really important. So you're going to decouple the act of delivering code to that automated deploy, deploying code, remove that from actually, decouple that from delivering the features to the users. And then the last 2 pieces, what I usually talk about are using production metrics and real-time alerting to gauge the effects of that code once it's been delivered. So just brief history, at least as it affected us, of feature flagging. And I know that there's a lot of people here from companies like Google and Facebook and LinkedIn and web scale companies, either from the 1.0 or early 2.0 days. And while I kind of can only assume that many of you, if you're in the room, had tools like this, for the rest of us in the unwashed masses, it was this post by Flickr at the end of 2009, I think it was Ross, about how Flickr was using feature flags, or I think they call them feature flippers, to allow them to basically always deploy from trunk. And at the time, I think John Allspaw used to talk about, deploying 10 times a day at Flickr, which sounds kind of laughable now. I think the Etsy talk is deploying approximately 72,000 times a day or whatever they're doing. And a big part of that, though, is they got rid of all the kind of really complex branching logic and deploys required to get new code, because just a really simple, insanely elegant construct, and this is literally the whole thing, you just wrap a conditional check based on some named feature flag or toggle, and then you decide actually at runtime if the feature is active for this particular user or set of users, we do the new cool stuff, otherwise we do boring stuff, the existing stuff that we know to work and is stable. And I believe then they were using probably a config file, I think, which is kind of interesting, or you could actually set flags on the user records to do this. But it was lighter weight, much more granular than like blue-green deployments. And it also really reduced the needs for rollbacks because you could at runtime throw a flag on. If something went wrong, you didn't need to roll back the code. You could just deactivate the flag. I remember being really excited. I think it was a couple months later when I read the post and I dug this up off of Twitter. Because a key thing is if you've been doing this long enough, you know that literally you think of everything in advance of how a user will misuse some feature, and you miss at least half of them. In the particular space I was in, or we were in at the time, so it's kind of more the Ruby on Rails web development world, I think probably where most people, if they hadn't seen the Flickr post, about 6 or 7 months later at GitHub, they blogged about how they used it for their organization's features, which was cool. In this case, they were using it on the user records. But kind of the really important final piece, I think, in that community was a guy by the name of James Golick. Introduced something called Rollout. And what was neat about Rollout was it attached to a Redis server and gave you some pretty nice primitives to, you could either flag users, flag groups of users, or flag percentages of users. And you didn't have to put any custom code in your MySQL database. It was an atomic set you could access from different places. There's lots of trade-offs that come along with Redis. We'll see how those kind of grow. Okay, so how did that impact us in our infrastructure? So we're built on AWS, and our primary interface with our users is a RESTful API to which you can emit metrics from any of the monitoring tools you're already using today. So a big part of when we came out that was really different from us is we didn't hand you an agent. It was kind of like the Seinfeld of monitoring tools. It was a monitoring tool about nothing. You had to bring your own data collection. So people measure things, configure their monitoring stuff to throw metrics at us, and we catch them. And then we give them suites of tools to visualize and correlate on them. So back in time, 2011, late 2011, early 2012, so we were building out the initial version in closed beta, and we ended up launching in March 2012, so just to about 3 years ago now. So it was really simple at the time. Data collection is everybody sending stuff to us. Our API was this Sinatra application, which is a Ruby framework. We put the data in a Cassandra cluster, and then we had a Rails app that served all the JavaScript and dashboards from it. So very simple Ruby and Cassandra-based implementation. 2 services, really, in front of the database. So this is a pull request on January 2012, where about 3 months prior to the GA, we actually integrated the rollout support, so now we could set that stuff up. And we do a lot of chat ops, which is interesting because for talks like these where you're doing almost kind of archaeological digging in your own company's backstory, you pull out, and I blacked out the stuff that's not important part of this conversation here, but you can see a quick exchange around that time where Mike was like, oh, this doesn't need too much memory, why? And Matt says, not really, and Mike says, okay, well, I was thinking like a micro or an m1.small would work, and Matt says, yeah, that's probably fine. Remember this, because it's interesting how decisions like that come back. So that was the first key thing to get set up. The second really important piece was for the next couple months we could log into a web console on a production server. So you deploy your code. If you want to toggle a flag, you log into a production server, open up the Rails console, say, okay, set this flag for this user through the gem that would talk to Redis. It's fine. But we found that was really clunky. You know, we had our automated deploy system, so I could just say, hey, go deploy this branch or this tag off a master. But then I'd have to log into a server to set a feature flag. And so we ended up writing, because as CTO I'm always like trying to avoid doing real work. I took it upon myself to write a plugin for our bot that does deploys to actually also toggle flags. So then you could do interesting things like this. You could tell the bot like, hey, roll this out to this percentage of users, or actually just query what's the current state, what groups and users have access to this. So this was kind of the second key piece of our system. So now we're going to fast forward about a year. Remember, original infrastructure, about a year later. And the original infrastructure at the time was doing, when we set that all up, like, I don't know, 50 metrics a second, maybe 50,000 writes a day or something really, really, I remember even pre-general release. About a year later, our system now looks like this. We've got stream processing, we've got polling going out, we've got a new alerting system in place. We've got rich analytics and queries, a whole slew of new services now. We're doing about 3 orders of magnitude more traffic at the time, so now we're doing like 50,000 writes a second instead of per day. And we're starting to add services in different frameworks. So whereas before we were just Ruby and Cassandra, now we've got JVM-based apps. We've got our log processing framework was written in Golang. So we're now a polyglot shop, but our feature flagging is still only available in our front-end instances, right? So now we've got to do weird things where we either kind of hack in the front-end API before the back-end services to prevent traffic from getting there, or we've got to set environment variables or other things like that. And then from a performance standpoint, somebody noticed around that time that our API request times have been really getting much higher than they should have been or should be. So it was now on average, in this case, about 400 milliseconds, or spiking in the worst case. So Mike went digging, put in some custom instrumentation, because that's what we do is, we do instrumentation all day. So we actually wrapped all the paths that could cause things and found that, when we're hitting close to 500 milliseconds, there's actually 2 feature flag checks in that hot path, each of which was hitting close to 200 milliseconds because that was the timeout to Redis. And then, basically he looked in a CloudWatch, the m1.small we had set up a year and a half ago is now just literally smoke pouring out of its ears 24/7. There hadn't been an alert set on that. So the very first thing was, okay, let's throw some more money at this, right? Upgrade that to a C3.extra large or something like that. Get the data over. But then you can see kind of immediately at the bottom of this discussion, Mike was like, all right, was our infrastructure data guy, and he's like, we're going to have to move to something else, like Redis, single-threaded, single-core, which is great at small scale. So we're going to need something maybe like a 2-node Cassandra cluster. I mean, we knew Cassandra well. But it was one of those things that we just put aside for the time being for a couple months once we bought the headroom. So 2 things changed. One is by September 2013, we'd raised our A round. We'd hired a bunch of data engineers. And the other thing is that the team at Papertrail, which is another great company in our space that does log analysis, had published an adapter for the rollout system we were using to ZooKeeper. And probably everyone here is familiar with ZooKeeper, but it's a great system for doing things like service discovery, leader election, distributed synchronization of configuration and state. And so we ended up using it for that. We put all the feature flags in ZooKeeper, so then each process, each service could put a watch on that ZooKeeper data set. Any changes would get downloaded into the process and be sitting there resident in memory. So now feature flag checks went from hitting a single point of contention, a Redis server over the network, to actually literally just checking values in memory. And additionally, and you can find these on our GitHub page, we added adapters for Java and Golang. So now, with this system, we can toggle feature flags directly from our chatbot. We can have a single set of global flags that our polyglot environment, Ruby, Java, and Golang can all go off of. And there's almost 0 cost to check them. This was by September 2013. You can see Collin, who we'll be talking about a little bit more, was very happy at the time. So this was where we ended up with scaling through that. This is a very good place to be from our experience in the next year and a half up to now. So I'm going to walk through now, the title, the titular character here, Collin and the Slingbot. So Collin lives just north here in San Francisco. We're a distributed team, but he's one of the people who works in the San Francisco office with me. He lives with his cat. And he's a Java programmer with a somewhat cynical worldview when it comes to computers, which I think kind of works in his favor as a protagonist today. And what I want to talk about is how Collin rewrote our service or our integration with AWS CloudWatch for our customers. So I don't know how many people here are on AWS who've used AWS, but if you've used anything there in production, you're probably familiar with CloudWatch, which is their, I will charitably say, minimal implementation of a metrics and monitoring system for any of your instances. And it's probably not a surprise that our customers, one of the most common requests we got was like, hey, I want to get my data out of CloudWatch and into your system with all my other metrics and dashboards and alerts and everything. And so what we did was in, I think, like early 2013. We kind of rapidly prototyped out to even see if this would work, a Ruby-based system we call Cloud Snarf, which was just pull all the data continuously out of AWS. And Snarf was chosen, the definition of Snarf is eat or drink quickly or greedily. And all this system does is make API calls to AWS on behalf of our customers. But I always prefer to think of it like this when I look at it, because I'm a kid of the 80s. And it also is kind of like what happened when we started putting enough load on the system. So we initially started it on just some M1 extra larges, but as customer demand grew, the service expanded up to literally we were running like 30 of these M1 extra larges for two reasons. One is that the CloudWatch API is pretty awesome, and every single number you want to get out of it. So say you have an EBS volume, they track 8 metrics on it. You have to make 8 independent API calls to get those 8 metrics. And you have to do that every 5 minutes or every 1 minute, depending on what frequency you have. And so Ruby was great for kind of really throwing, like rapidly prototyping and developing web-based services. It's really easy to interact with APIs. But what it's not great with is concurrently making tens of thousands of API calls that block on I/O. Because each of the Ruby workers you have has a full memory footprint. It's a heavyweight process, so it's like 200 plus megabytes. And so what would happen is we'd have these workers, load would get to a certain point, the killer would start getting involved, CPU would start thrashing as well on some of these things. And by percentage load, that's really what it looked like. So in addition to it being like overly expensive, instead of kind of like cleanly blocking in front of the queue when it hit full load, it actually got really wonky and we'd have to manually power cycle and stuff. And the dependency tree, this is kind of the basic system. Just a set of worker nodes there in the middle. They're all running the same copy, so we had hundreds of these Ruby processes running, and they were using ZooKeeper to perform a leader election every cycle. Whoever won the leader election became like the queen bee worker and would interact with the top level API of Amazon to enumerate all the instances that we needed to go get the data for. Put all those metrics one by one into an SQS and then all the other workers would basically pull those jobs off the SQS queue, use the metadata in our MySQL backend, make one API call, and then turn around and push that number into our API. So it's really just like a very simple JSON fetcher, right? So that worker would get one metric off the queue, push it in, just repeat that. Now the problem is, since we had a lot of these to do, especially as you said scale, we had all these processes. So what we decided to do was that if we were to then switch to a language like the JVM or Java, which has a much stronger concurrency storage, has a much better with the the JIT compiler for things like doing JSON serialization and deserialization. So we could run more workers per box and cut down the number of instances. Also, try to turn this into more of a compute block problem instead of memory block problem, because compute is much cheaper on AWS than memory is, pretty much anything. So Collin's mission was to re-implement this service in Java. And it wasn't a big task for him or anything he was scared of, because that's the thing that people who wear Basho t-shirts tend to get excited about, is making distributed systems more effective. And the tricky thing for him was that we had hundreds of customers already and adding more every day who are using and relying on Cloud Snarf. So if you think of the data flow from left to right, here's Collin's predicament, right? The guts of the service right here, the memory inefficient service that's costing too much to run. We need to replace that eventually with a new service that's going to have those new sharp edges, going to still have some bugs in it, and do that without impacting any of our existing users. So we could do that, we figured, by having two separate queues, right? Two separate queues, and then using our feature flagging in the leader code to actually decide which of these queues to put it into. And this is slightly atypical, I think, at least from, what I find more common, and we were discussing just before the talk, is that even where we came from originally when I helped build the system was that feature flagging is thought of as this like user-facing thing. So which version of the UI do you get? Do you get that extra button in your UI or not? And what Collin went and did was to use this kind of much more in the hot data path and decide which way the data should go here. So we check each incoming metric against a feature flag. The leader uses our rollout information to select between two different queues and put it into the new service we call Slingbot. And here's just an example of that code. And you can see it's got setting up its queues, and then it decides if the rollout active, the CloudStar Slingbot service name, it adds a second queue. And if you squint, that's actually a little different from what I just described. This is the very first commit. And that was because Collin did a pretty, I think, clever thing. And that was on the very first implementation, if the flag was on, it actually teed the data off. It sent it to both services. So our original and efficient service still remained 100% the system of record, but our second system now could start to get exercise with production load without being responsible for getting the data in cleanly and correctly. And you can see him actually, this is the chat log of him actually doing this in chat. So you can actually see the first few minutes of Slingbot's life here. So he actually checked it in staging. It's alive. Check the current state. Here we can see that only user ID 43 has it. And he spent the rest of the day experimenting with this replicated production traffic in staging. So on day 2, we went ahead, and now we're in production. And what we did is we said, OK, let's enable UID 1 for this service. And for us, UID 1, as you might guess, that's our actual own account where we're tracking our metrics in. And one of the cool things, or typically feature flagging, is you'll see as hierarchy of like, OK, we're going to give staff access to this. Then we'll give like maybe some beta users access to it. And then maybe some percentage of all users access to it. And then everyone. So you can get this really controlled curve of access, very granular. And you can actually see in the graph there, that's when it kicked off the production usage. The other thing that I thought he did was pretty clever that was specific to this kind of use case is that because we have a different handler internally for each AWS service, even more than just like per user, he also went per user service, right? And so we came in, and for each event handler, so we would just say, let's turn this on for this set of users for SQS. And take a very procedural approach to this, right? SQS, go through EC2, and get each one nailed. So you could code in one place, flag it on, test it, move to the next piece. So if you go through the chat logs over the course of the next several days, he was kind of methodically bringing these up one at a time. And here's a graph of the queue. Now, the impact of our service of each of those AWS services is not equal because there's a lot more EC2 instances than, say, like RDS instances or ELBs. And so that kind of jump right there near the right-hand side was probably turning on EC2. You can also see where overlaying the deploys is vertical lines. So that's kind of useful. You can see the effect a deploy would have. In particular, that must have been the EC2 deploy. And we're also keeping a very close count on the number of active workers. It's using one of the nice things about the JVM, we could set up a thread pool, and we could go from either 50, I think by default it runs like 50 threads on a JVM instance, but it can burst up to upwards of 250. So if you see that bursting up, then we know, okay, we've hit some contention, we're starting to eat into our buffer, and we can go take a look at what's going on. And kind of this just very early initial set indicated to us that we'd be able to cut our instance count like in half, moving to the JVM. And that made the CEO happy, which made me happy, which made Collin happy, and then that in turn made Collin's cat very happy in very quantifiable ways. Now, on the next day, on the third day, also a good idea, what we did is he added just a bunch of different users, right? We'd only been testing on one user, so we added a couple users who didn't really have any data just to make sure that the UID handling didn't have any sharp edges. And I think what's really interesting here is to see the progress. You can see a couple dips after deploys, right? And what's interesting here is we do deploy, flip on some traffic, find a sharp edge, right? But then what's nice about feature flagging is you just turn that back off. You don't have to, you don't have to do a rollback, right? You just turn the flag off, it goes back to the safe path. Do another deploy with a potential bug fix, dial it back up, see if it works. If so, move forward. If not, turn it back down and repeat. And you can see that pattern repeated here over time. So after a couple weeks of this, now Collin was ready for, and Slingbot was ready for kind of more serious. We've been doing this on a handful of users. We'd use feature flagging to allow us to functionally test all the different things we had to implement against our own account as a guinea pig. Maybe even brought in a couple of trusted users that we knew would reach out to us directly if they had problems, and we also would do this with their knowledge in advance. But now it was ready. It was time for the big leagues, right? So we see here is we actually just rolled out and said, hey, we're going to take some percentage of our production load and put it through this new system. And he's enabling it for 15%. So in effect, this capability in our feature flagging system is giving Collin a knob that controls the volume of the inbound traffic into Slingbot. So when he turns the volume up, we can see that it comes heavily into this one, and when he turns it back down for whatever reason, it goes back into the other one. Now this is my favorite slide in the whole talk, and this is I kind of vividly remember Collin literally sits next to me. I can kind of reach him if I try. And I remember being in chat, and this reads from the bottom up, right? And seeing this kind of pattern and kind of asking what was going on, because I didn't understand like all the up and downs. Also because there were no deploys interspersed here either. This wasn't a case of like doing a new deploy, making it safe. And so what happens in the typical day of how Collin used this was, he'd come in and get his coffee, turn it up to 15%, and then like as he became more and more caffeinated, get it up to like 30%, 50%, 75%, right? It's too bad this doesn't have timestamps because this is basically lunch. It's time to go get lunch. So Collin dials it back down to 25% and go grabs a salad or $4 toast or whatever he's getting for lunch that day up in San Francisco. Then he comes back from lunch in the afternoon. We have a decent amount of our ops staff on the East Coast, so we didn't take it all the way back up to 75%. And then before he got on his bike to head home, he dialed it back down to 0%. And he literally did this over the course of the next couple of weeks, or every day he'd come in, it was like punching his time card, he'd turn it back on, and this was a great way. We never got paged during the night for this system through the whole course of developing and rolling it out because it literally was never running at night. And that's something that I never have conceived of when I actually helped build the original system, so I thought that was really neat. And here's over time, and this is not showing as many of the dips, but you can see over time we finally get up to the full load on the right-hand side. Okay, so now at this point we've successfully replaced all of the workers, the JVM workers, all the Ruby workers with JVM instances. Instead of cutting it down by half, we went from 30 of these M1 extra larges to like 6 C3 extra larges, which like not surprising in retrospect, but was certainly very nice to happen. So big +1 to the JVM. But we still had a piece of the Cloud Snarf code with us. That was the leader, right? The thing that got elected leader and actually enumerated the metrics. That was still the Ruby code. Not as big a performance problem because it was, it wasn't the at scale piece. But now it's a separate code base. We didn't want to maintain 2 paths. So now we decided to also port that over to the same JVM code. So the last thing he did was we added the same leader feature to our Slingbot. And we ran them both in parallel, and we just kind of let the API sort out the duplicates. And then with kind of the flagging and percentages, over time we slowly began decreasing the percentage that the original work was doing, so it would kind of sleep for longer and longer periods of time until finally, one day, it was just never woken up again. And this system now, today, processing on the order of, it's like, 10,000 metrics per second, which is actually literally 10,000 API calls per second, or a little north of that, into the CloudWatch API, which makes the CloudWatch team very happy with us. And we're doing that with a P99 in the new system now, less than 325 milliseconds. What We're doing anywhere, like I said, the thread pool goes from 50 to 250 workers, which is really nice, and it's only 2.5 gigabytes per instance, whereas before we were upwards of like 60 plus gigabytes with all of our kind of fat Ruby processes to do that. And we're pretty comfortably over provisioned still on those 6 C3 extra larges. Right, and so, although Collin and his cat may not always live happily ever after, the joys of feature flagging certainly have strengthened their relationship, we think. And that was the kind of primary detailed exercise. Something that's pretty recently happened that I thought was interesting and worth covering here is an exercise. This is actually still ongoing. It's a very similar exercise, except the very last piece of our infrastructure, the hot path, right, of metrics coming in that is on Ruby, is a piece of the original Sinatra app that literally just deserializes JSON and then pushes it into Kafka. And then the whole rest of the hot path is JVM or Golang. So we've been working for the last, and this is doing, I forget how many 100,000 metrics a second, but it's, for us, it's a very high throughput path. And so we've been working on moving that last piece over to the JVM as well. It's fronted by Nginx. Now the interesting thing was, we said, okay, how can we get Nginx to allow us to have these same kind of toggles? And so it was really 2 pieces. The first was Nginx allows you to write Lua plugins. So our ops engineers wrote a very simple Lua plugin that provided access to a set of feature flags, could decide whether to pass that traffic onto the original API service or onto the new service called Jackdaw, which I think is a video game reference. Our data team picks really esoteric names for things. The second piece was, I guess in theory we could have, and we may still write a rollout plugin in Lua or something like that to do the ZooKeeper watch. But the pattern we ended up going with in the interest of doing this quickly, and we got the idea, Twitter has this project called Twitcher, I think it's called, which allows you to have scripts execute when ZooKeeper watches change. And so we wrote a little Python process modeled after that, which watches the ZooKeeper the feature flag set, and then when it changes, it writes the updated set into an Nginx config file, and then basically prods, I forget if it's sig hup or whatever, but prods Nginx to reload its config. It reloads it, it has a new set of feature flags, and then the Lua plugin makes the new choices we've decided to have it do. And so now we can dial up literally our whole production traffic between one of these 2 services, which is really powerful for us. And it's just another example. I mean, this literally, I wanted to dig in. So this is a transcript from November 20th last fall. And so this is basically, for the most part, the 4 members of our data engineering team, and we're hiring if anybody's interested, but all working on separate features. So that's about 50. And here's the rest of it. So over the course of that day, I just kind of randomly picked it. This isn't necessarily a high watermark. The 4 of them interacted with the feature flagging system just over 100 times on 4 separate features that they were working at concurrently in the hot path. And I did get a couple metrics. So since we integrated the feature flagging system with our chat ops system, it's been about 687 business days. There's been a total of just north of 4,500 interactions with the feature flagging system, which means we're averaging, for going now 3+ years, 6 to 7 a day. And obviously, as you can see, it's much, it's a fat-tailed distribution. It's much higher now than it used to be because we had 5 engineers at the time, and now we're up to about 15. So just 2 things. So conclusions. If you're not doing this, definitely do it if you take nothing else away from that. If you are doing it, the best practices we came across or ended up getting to because of our workload brought us there, store the things locally in memory and synchronize them, whether it's through ZooKeeper or console or some other system. Use a single set of flags. This shouldn't be like just a front-end piece that your front-end engineers have. Like your back-end team, every service, if you're doing microservices, they should all have access to the same set of features. And that's especially critical because you never know like how many services are going to touch the same request as it comes through and need to know how to handle it. For us, we found, I mean, we did it through ChatOps, but you can do it through a UI or something. But having, just like we have one-click deploys, having one-click interaction with feature flags, toggling them up and down or the equivalent is really crucial. And then definitely always graph the impact of throwing those toggles. Like if you throw a toggle, you should be watching a chart move in reaction to that. And something just like literally 10 days ago, I was working on these slides and this came across. I mean, we used ZooKeeper with this Rollout gem and a couple of adapters to ZooKeeper. That's been a great system for us, and we have it integrated both with Campfire and now we're on Slack, so that system's available. But the Pinterest team has pushed out now like a really cool system that that starts the blog post talking about configuration data like spammer blacklists. But you can also push out, they have a system called Decider if you go down the blog post. And what's neat about this, at the scale they're at, they use ZooKeeper to communicate that the flags have changed, but the flags are actually stored, I think, in S3. And so they don't have scale problems. Your ZooKeeper watch tells you the flags have changed, and then something in your code can actually pull down the latest value from S3. So you don't have problems with ZooKeeper communicating with literally thousands upon thousands of nodes, which I thought was an interesting way to approach that. Okay, and so I'm coming a little in under the gun. We're hiring, and if you catch me now, any questions before I homer myself back into the hallway track for the rest of the conference? Cool. Oh, wait. Great. Awesome.
Yeah, so on your last slide, one of your last slides, you had mentioned that you should track the effect on track and measure your revenue impact on based on flagged features. I was wondering how you typically do that, especially if you have events that need to be emitted to a Hadoop grid or whatever, and there's a lot of post-processing that needs to happen.
Yeah, that's a good question. So I think at least the way we've done it so far, I mean, I had mentioned our kind of deploy markers on our graphs, but that system actually lets you, and many graphing systems will let you push like arbitrary events in. So in addition to painting deploys across a graph, you can also paint like toggles. As well as if you have a back-end system, if there's some batch processing job, you can actually even overlay the duration of that on the charts. But that's generally been the way we accomplish that.
Okay, thanks.
Cool. Yeah, thank you guys.